Okay, so for question number 2 on this worksheet, instead of looking at the contains method, we're going to now look at the insertion method for binary search trees. So as the instructions say at the top, what we're doing is we take our tree, and when we insert a new value, we find an empty spot at the bottom of a binary search tree, so that the new item is always going to be a leaf node. This is the technique for inserting into the binary search tree that we've previously looked at. So 2a just asks us, okay, draw me a tree if we're adding the items 1, 2, 3, 4, 5, 6 in that order. So let's just take this step by step, one at a time. So first things first, the first item to draw is item number 1. So let's just say we're starting with an empty tree. So first things first, I have a single tree with one node, and it's number 1. Okay, next we're going to add number 2. So remember, with the insertion algorithm, the first thing we have to do is we have to decide where to put the new node. So we compare it to our root, which is currently 1, and we say, okay, if it's less than our root, then we put it to the left subtree. If it's greater than our root, we put it to the right. So 2 is obviously greater than 1, so we'll put it in our right subtree. Same thing here, we'll go with number 3. So we go, okay, compare it to the root. 3 is greater than 1, so we look in the right subtree. 3 is still greater than 2, so we add it to the right subtree of 2, and we add that there. As you can see, there is a pattern forming. So for number 4, 4 is greater than everything so far on the tree, so it goes in the right there. 5 in turn is greater than 4, and 6 in turn is greater than 5. So essentially, what we see is we get a binary search tree. This is a valid binary search tree, but you see it's really just connected in one direction. There's only right-hand subtrees. So let's look at a tree which has exactly the same values, 1, 2, 3, 4, 5, 6, but we're going to insert them in a different order. So this is for B. So the first one we're going to insert is 4. So we're starting with 4 as the root of our tree instead of 1, which is what we had before. So now we insert 2. Well, 2 is less than 4, so we put it in the left branch. 3 is less than 4, so it goes into the left branch as well. But then we compare it with 2, and we know that 3 is greater than 2. So we'll put that one in there. Next one is 5. Well, 5 is greater than 4, so let's throw this one in here, in the right subtree. Now we look at 1. Well, 1 is less than 4, so we look in the left. 1 is also less than 2, so we can add it here as the left subtree of the 2 node. And last but not least, well, 6 is our last value. 6 is greater than 4. 6 is greater than 5. So we can put it here. All right, so as we can see, 2 trees. Same value stored in the tree, but the order that we insert them means that we end up with 2 very different looking trees. So question number 3 just says, okay, write down the height of the binary search tree you drew in the previous question. So in 2a, well, we've got the height is 6 because we go 1, 2, 3, 4, 5, 6. We have 6 values there, all in a row. For 2b, well, the height is actually much shorter. It's just 3 because we've got 3 in this branch, and that's the maximum height in kind of no matter which branch you go down, you're only going to ever get to 3 levels down. So just to recap these two questions, same values, different insertion order, and you end up with very, very different heights.